Up in this video here, we're going to be looking at the solubility curve. Alright, so what does solubility mean is what we got to tackle first. So here, looking at this, a couple definitions. This is the fancy formal definition. Solubility is a chemical property referring to the ability for a given substance, the solute, to dissolve into the solvent. It is measured in terms of the maximum amount of solute dissolved in solvent equilibrium. Equilibrium is like when some of it is dissolving, but some of it is reforming. So there's this balance. That's what equilibrium means. Think about when we talked about, hot objects and cold objects. Hot will give heat to the cold. Cold will release heat until they're balanced. All right, so basically this is kind of what I like to say here at the bottom. Basically the term solubility is used to tell you how much solute you could put in a solvent before it becomes saturated, with saturated meaning full. Before we get started too much, I got to look at a couple words here. So the solute is dissolved into the solvent. When the solute and the solvent come together, they form the solution, which is a homogeneous mixture. We've talked about the electrolyte, should be familiar with that by now. Rated dissolution, we did the lab on that. This is just basically, how fast does it work? How fast does it dissolve? And then temperature. Big definition for us this entire year, average kinetic energy. All right, so looking at this is our solubility curve. I basically just put this blue box over our curve. So the only thing of our curve we can see is what's on the Y and what's on the X. So that's a terrible X. So looking at the X, we have temp. So this is temp, right? Starting at 0, working towards 100. So we have an increasing temp. So it wouldn't matter what our line looked like. So whatever our curve looks like, whether it's going up, whether it's going down, I could even draw it this way, right? Or this way. All of these are increasing temperature, right? All of these are increasing temperature. It doesn't matter, right? It doesn't matter. As long as we're moving from left to right, we are increasing temperature. So now, as we increase temperature, see if I can change color here. Nope, don't know how to change color. All right, still new to this. We have the solubility over here. All right, so as we change temperature, something could happen to the solubility. If our line moves up, this means we are going to increase solubility. My line moves down, we're going to decrease solubility as the temperature changes. All right, moving on. So when we get ready to look at this graph, it's very important that we identify the solvent information. Right, the solvent information is found right here. This just tells us what is our solvent and how much there are. So as you can see, these two graphs, right? These two graphs have the same solvent, being water, but they have different amounts of water. Right, so they'll give you different results. This over here has a different amount and a different solvent altogether. So just make sure you take the time to look at your solvent to make sure you know what you're dealing with. All right, so here we actually have a solubility curve. This orange line right here, I'm not real sure what it's called. I like to call it the saturation line. This tells us where a saturated solution is. So I can look, say, at 20 degrees, right? I know at 20 degrees for this element, right, there's about, 31 grams of solute forms a saturated solution. Or maybe at 60 degrees, I go up to the line, right, go over. This ain't going to be quite perfect, but, pretty close to 80 grams of solute forms a saturated solution. All right, but what if I ended up here with more than 80 grams or less? Or what if I ended up with more than 31 or less? We need to be able to describe that, and that's what this section over here is for. We're going to describe it as supersaturated or unsaturated. So our saturation line is like through here. Okay, anywhere on this line is a saturated solution. But what if I had over? So say at 30 degrees, I put in 60 grams. will give me a plot point somewhere right there. This is above the line. Anywhere above this line is called a supersaturated solution. Or what about if at 50 degrees I put in 35 grams? Well, this would put my point right there. This is below the line, so this would be an unsaturated solution. If it's on the line, saturated. Above the line, supersaturated. Below the line, unsaturated. All right, so we're going to work through a couple here. So looking at number 1, right, we're trying to figure out if it's saturated, unsaturated, or supersaturated. So 60 grams, 90 degrees Celsius. So 60 grams, right, where are we at? 90 degrees Celsius, right there. So this is above the line. Okay, this is super. Looking at 2, we got 100 grams, 55 degrees Celsius. So 55 degrees Celsius, 100 grams, right, above the line. This is super. 80 grams. So 80 grams at 80 degrees Celsius is going to be here. This is below the line. This is unsaturated. And then 54 grams at 50 degrees Celsius, that's going to be right there. It's dead on the line. This is saturated. Look at this one, a couple more. Now we have 2 lines to deal with. We got a sugar line, we got a salt line. So looking at number 1, it says 200 grams of sugar, 20 degrees Celsius. So at 200 grams of sugar, 20 degrees Celsius, that puts us right there. Okay, this is saturated for sugar. Now, if it would have asked us 200 grams of salt, it would be above the salt line. So in that case, it would have been unsaturated. But that's not what it asked us. What about number 2? 2 says 40 grams of salt at 10 degrees Celsius. Sorry about this. I forgot to fix this, but this is supposed to be 10 degrees Celsius and 50 degrees Celsius. So 40 grams, 50 degrees Celsius. So here's 50 up to, I think this is supposed to be 400. We'll call it 400. All right, sorry. 50, 400. Okay. Oh, no, I'm right. My bad. So 40 grams, right, at 10 degrees Celsius should be right there. Okay, this is going to be saturated. Sorry, I had a brain fart there. Looking at number 3, 150 grams, 50 degrees Celsius. So 50 degrees, 150 grams. Now both of these points here are the same. So for salt, right, it's above the salt line, so it's super. But it's for number 4, it's below the sugar line, so it's un. So depends on what line you're looking at. All right, take a look at this. Keep your eye on the y-axis. So what we got to understand by that, we got 100 mils of water. So how much ammonia gas can be dissolved into 50 mils of water? So here our solvent in our question is 50 mils, but over here our solvent is 100 mils. So we'll use this graph to figure out at 15 degrees Celsius, right? 15 degrees Celsius, I can put in 600 grams into 100 grams of water, right? I want to know how much can I put into 50, right? So 50 is half of 100, so I'll be able to put in 300 grams. That's my answer for number 1. Number 2, how much ammonia gas can be dissolved into 200 mils of water? So that's going to be twice this, right? First, let me use my graph to see what we got. So we'll go 50 degrees Celsius, which is right here. All right, we're going to go up to my line, right, which is about, this graph tells us I can put in about 250 into 100. I want to know how much can I put into 200. This is double, so this is double. So it'd be 500 grams is my answer. All right, so then we see this here. If you remember, the density of water is 1 gram per mil. So 1 mil of water is going to equal 1 gram of water. That being said, so how much ammonia gas can be dissolved into 100 grams of water? So over here in our solvent table, right, it says on the table our solvent's 100 mil, which is the same thing as 100 grams. So on this one, all we need to do is read our graph. So we just go to 30 degrees Celsius, we go up, right, 400. How much ammonia gas can be dissolved into 1,000 grams of water at 0 degrees Celsius? Well, on our graph here, it says at 0 degrees Celsius, we can put in 900 grams in 100 mils of water. We want to know about 1,000. This is times what, 10, right? So our answer is 9,000 grams. All right, so now we'll just put it all together, getting ready to go into this. Let me know if any questions. I feel like I was very boring with this one. Don't get scared. It's just a bunch of graphs put together at the same time. Some are more soluble. The ones that go up are more soluble, right? The lines that go up. Some are less soluble. These will be the lines that move down, right? The solubility is barely even affected on some. These are the ones that just kind of stay pretty flat. And it's not any different than anything we just covered, right? It's just all at once. Focus on one line at a time. All right, see y'all later. Let me know if you need any help, further explanation of any